So the next exercise we have of composition of functions. So what is basically composition of functions? Suppose we have one function that is f of from a to b, and we have another function that is g of b to c. Now the composition of these two functions will give us, so composition of these two functions of f and g is given by g of f. This is how we write composition of two functions. Now this function is denoted by g of f colon, it will be a to c. Clear? So what we have in here, so in place of g of f we can write it as so g of fx. So basically fx is present inside the g function. So what is for all x element of, now look at here, x is an element of what? A, right? Because it's starting from the function a. So for all x element of a we have g of fx is given by like this. Now if I have to explain you diagrammatically, this looks like, so suppose we are going to explain this one arrow diagram. So we have two figures like this, three figures like this. Now here, from here, this one is A, this one is B, and this one is C. So from A to B we have the function f, and from B to C we have the function g. And the composition basically means what? Directly from A to C. This is the link, and this one is denoted by g of f. That is what composition of the functions f and g. Now the next one is inverse of a function. Now this one is composition of function. Achha, fine, let me go through one example. Suppose we have fx as sin x and gx as x square. Suppose we have fx as sin x and gx is equal to x square. Now if somebody asks you what is the composition of f and g, what you are going to write? So you are going to write g of fx is equal to g of fx, and what is fx? Fx is sin x, so you write inside g, you write sin x. So you see, in place of x, gx is what? X square. So basically I will just put an underline in x. So in place of x I just need to put sin x. So this one will be what? Sin x whole square. So that's how we do composition of two functions. I hope it's very clear. Now we'll go into inverse. So what is inverse of a function? Now let's discuss that. So a function f a to b is said to be invertible. This is invertible. Now what is the main criteria for this one to be invertible? The criteria is that if there exists another function g of b to a such that g of f is equal to ix, and what is ix? Ix is the identity function, and f of g is equal to iy, and f of g is equal to iy. So if these two conditions are satisfied, then we can say that the function g is the inverse of f. The function of g is called the inverse of f, or it is written as f to the like this, f inverse. It is denoted by f inverse. So when can I say? So a function f from a to b is said to be invertible if there is a function g from b to a such that g of f is equal to ix. Actually it won't be ix, it will be ia. It will be ia because here the function is from a to b, right? So it will be ia, and here it will be not iy, it will be ib. You see the domain portion, g of f, the domain portion is a, so it is IA. The domain portion g is what? The domain of g is what? B. So here it will be IB. So basically IA is nothing but the identity function of A, and the IB is the identity function of the function g. So you will be getting g of f as IA and f of g is equal to IB. Then we can say that the function is invertible. Let me go through one example. Suppose I have a function fx is equal to 2x. Now if somebody asks you where x is an element of R, so you have to tell me whether this function is invertible or not. So what we are going to do is, let us assume there is another function, one thing we cannot, and the function is from R to R. So this is how we define the function. So here we have to check whether this function fx is equal to 2x is invertible or not. Clear? So now the first thing what we are going to do is, we will assume a value y. Let there be an arbitrary value y, such that y is equal to fx and that is equal to 2x. So from here y is equal to fx equal to 2x, we can write x is equal to y by 2. We can have this x is equal to y by 2. So by this way x is equal to y by 2, we can define a new function gy. So now let us define a new function. So what we are going to write here is, now let us define g colon r to r. I am defining a new function by, what is a g function? You see, the g function will be gy is equal to y by 2. This is my new function. After defining this function, what do we have to prove is that we have to prove that g of f is equal to IA and f of g is equal to IB. So let us find g of f. So g of f is equal to what? It is g of fx, because x is a part of fx, right? The function f. So g of fx. Now what is fx? Fx is 2x. So I write g of 2x. Now you see, gy is y by 2. So g of 2x will be what? It will be nothing but 2x by 2. So in place of y I will write 2x. So 2 gets cancelled. So we have x. So you see, g of f, you are getting x. Clear? So you see, g of f was IA, right? So g of f, you're getting x. So basically x was what? X was an identity function of f of x, right? F of x is equal to x. So basically we are getting the identity function of f of x, right? Now we will write what? We have to find f of g. So let us find f of g. So what is f of g? So it is nothing but f of gy, and that is equal to what? F of gy is what? Y by 2. You see, gy is y by 2. So we are going to write y by 2 in here. Now what is fx? Fx is 2x. But we have to find f of y by 2. So in place of x, I will write y by 2. So we have 2 into y by 2. So we get cancelled. So we have y. Now y is nothing but the identity function of g. So what you see, if I do g of f, we get the identity function x. Now if I do f of g, we get the identity function y. And since we are getting this thing, we can prove that, after this we can say that g is the inverse of f. Hence g is the inverse of f. Okay, so that's how we prove this. Now with this we finish up the discussion of this topic. We have only two things, that is composition and inverse of a function. Now let's move on and solve one problem. So I have already selected one problem, that is of exercise 1.3. So exercise 1.3, The question is question number 8. So here the question says consider f. So we have to consider a function f that is r plus 2 4 comma infinity given by, so the function is given by, let me write the function first, fx is equal to x square plus 4. So this is a function. Then it says show that f is invertible and the inverse f inverse is given by f inverse y is equal to root over of y minus 4. So they have directly given you the inverse function and you have to prove this thing, where r plus means the set of all negative real numbers. So it means basically positive real numbers. Okay, so now we have to find what? We have to check whether f inverse y is equal to root over what was that? Root over 4 minus y square. Root over y minus 4 is the inverse of this one or not. So we have to check this thing. Now for solving this problem, what we are going to do is the first thing, let us consider an arbitrary value y, such that y is equal to fx and that is equal to x square plus 4. So we are taking one arbitrary value y which is equal to fx and that is equal to x square plus 4. Now for what you're going to write is for all x element of, now what is the domain of f? It is r plus. So for all x element of r plus. Okay, so we have defined this thing. Now this shows what? Now we have to express this expression in terms of y. So can I write this one as y is equal to x square plus 4. So x square is equal to y minus 4. So therefore x is equal to root over of y minus 4. So we can write this thing, right? Now after writing this, so we see a new function, that is gy function, and that is given by root over of y minus 4. So what we are write? So let us define a function. Let us define a function g. Now here, whenever we are finding the inverse of a function, if the function is from a to b, the inverse of the function will be from b to a. The domain and range will reverse itself. So here it is from r plus to 4 comma infinity. So I will have to define the function g. It will be 4 comma infinity to r plus by what? By gy is equal to root over of y minus 4. So I have defined a new function, that is the function g, which is given by root over of y minus 4. Now after writing this thing, now what we have to do? Now we have to prove that now g of fx is equal to, we have already done this one, so it is what? G of fx. Now what is fx? So we have g of fx is how much? Fx is x square plus 4. So I will write here x square plus 4. So now you look at here, now you see the g function. G function is what? Root over y minus 4. So in place of y, you just put x square plus 4. So what do you get? Root over of x square plus 4. I am putting in place of y. Minus 4. So 4 gets cancelled. So it is square root of x square and we are having x. Okay. Now after this, what we are going to do is we are going to find f of g. So let us find f of g. Now f of g y is equal to y. Why we are writing y? Because here g is the function of variable y, right? So here we have f of gy and gy function is what? F of gy function is root over of y minus 4. So let us write in there root over of y minus 4. And now fx function was what? X square plus 4. So f of root over y minus 4 will be what? in place of x you write root over of y minus 4. So what I get, root over of y minus 4 whole square plus 4. So we have y minus 4 plus 4. This cuts and you have y. So what do you see? When you do g of f, you're getting x, and which x is the identity function of f, and when you do f of g, you get y, where y is the identity function of g, right? So by this way it proves that the function g which we have defined is the inverse of f function. And what was the g function? G function is root over of y minus 4, and you see that proves us that it is the inverse of root over y minus 4. So you write down hence the function g is the inverse of f and is given by f inverse y is equal to root over of y minus 4. That's it.